Good evening. Good evening, everyone. Good evening. Audibility is good. Am I audible clearly? Okay, thank you. Thank you. Yesterday, we started the classification of systems. The first system which we checked is linearity. Linearity definite requirement is obeying superposition. Sum of scaled input signal should produce as. So what are the general nonlinear operations we observed yesterday? General nonlinear systems are unknown signal product, x square or exponential form, natural logarithm, complex conjugate. Like that, there are multiple operations which are non-linear. Let us discuss the second system, which is called as a time invariant. Its other name is shift invariant. And a time variant means shift dependent system. The meaning of the word time invariant, it is included in the statement only. Time invariant. If the characteristics of the system are independent of time, then it is a time invariant system. If the system characteristics are not depending on time, that is called as a time invariant system. How to understand that point is, assume we applied a rectangular input to a particular system set. If you have retained the output graph something like this, if you have retained the output graph like this, if you are delaying the input by 2 units, means the rectangle covers from 2 to 4, output must be delayed by 2 units. Output must be delayed by 2 units. If you get other than this delay, or if there is a deviation in the shape, if you get other than this delay, or if there is a deviation in the shape of the output, then the considered system is variant system. Whatever the shift that occurs in the input, same shift must occur in the output. So mathematically, we will say like this, sir. If x of t maps to y of t, the meaning of this mapping is system operation we are using. X of t minus t naught should map to y of t minus t naught. What is the check for time invariance condition? How we are checking time invariance condition is, how we are checking time invariance condition is, output signal due to shifted input must be equals to output signal directly shifted. For a given system, first time you delay the input, next time you delay the output, sir. If mathematically the expressions are equal, then we can say it is invariant system, otherwise variant system. Generally, time varying nature of a system is caused due to aging of components. Aging means as years progresses. The best example we can say for a time invariant system is normal Ohm's law. V of t equals to R into I of t. Resistance is always a fixed value, sir. Normal Ohm's law. Variant system, we can give multiple examples. The speed of the rocket is function of its mass. Initially, it may go with higher speed, but once it reaches to higher distance, speed decreases because mass is decreasing. It means from beginning to ending, it is not maintaining the same speed. It is showing its varying nature. Not only that, Suppose you are going by your vehicle. If you are going by your vehicle on the road, based on the traffic, we are adjusting the pedals. We are not always maintaining the same speed, 60 or 70 km/h. Depending on the traffic, we are adjusting the pedals. Correct or not? Initial days, every electronic equipment will act like invariant systems, sir. Suppose we bought a new TV piece. Initial days, it will work properly. After a few days, due to aging of the components, it will start showing its varying nature. After 3 or 4 years in the TV, if some component is gone, then it will show what is TV for us. So the time varying nature of any system is caused due to internal components. If you want, note down the definition. If you want, make the definition, sir. A system is the TI. TI means time invariant. A system is a TI if the input output characteristics do not change with time. A system is TI if the input output characteristics do not change with time. So how we are checking time invariance conditions are mathematically. Observe the black box, green colored one. Output signal due to shifted input must be equals to output signal directly shifted. If output signal due to shifted input is exactly same as direct output delay, then the considered system is invariant, otherwise variant. For a given system, first time you shift the input, next time you shift the output. If mathematical expressions are equal, invariant, otherwise variant system. So let us discuss few examples on this concept, sir. Let us discuss few examples. I am moving to next slide. I am going to next slide. Y of t equals to t times xt. Is it invariant or variant, sir? I or V? Y of t equals to t into xt. I for invariant, V for variant. Yes, it is a variant system. Without solving, we can say whenever the input or output is external function of time, blindly it is a variant system. In this example, output is not only depending on input, external function of time means it is a variant system. Or let us verify mathematically what I said mathematically, sir. Output due to shifted input must be equals to output directly shifted. If you delay the input by t naught, we will say the answer is t into x of t minus t naught. But if you say delay the output by t naught, what is the meaning of delaying the output by t naught? Entire system expression t is replaced as t minus t naught. So y of t minus t naught is t minus t naught into x of t minus t naught. Whatever the expressions we got on the right side, they are not equal. They are not equal. That way also we can say system is variant. Output due to shifted input must be equals to direct shifted output. That is not happening. So variant. Suppose we are failing mathematically, sir. You can check graphically also. How? What is the system operation we are using now? System operation is multiply by t. Suno. Listen here. System operation is multiply by t. After that, we are saying delay by t naught. So let us take delay by 1 unit. Lower side, interchange the blocks are delay by 1 unit multiply by t. Delay by 1 unit multiply by t. What does the lower blocks denotes here? Output signal due to shifted input. Lower blocks denotes here output signal due to shifted input. Upper blocks are for the system we are performing delay means output delay. For the system we are performing delay means output delay. Suppose we applied unit step function as inputs are ut. The output graph here becomes tut like this. Delay by 1 unit means t minus 1 u of t minus 1. So it extends from 1 to infinity. What is the output here? Ut delayed by 1 unit means u of t minus 1. Here what is the output? T into u of t minus 1 means it is starting at 1 with amplitude 1. The signal is starting at 1 with amplitude 1. Of course, these two graphs are not same. That indicates it is a variant system. If you are failing mathematically, you can check graphically by taking system operation. In this example, what is the system operation, sir? Multiply by t. It is multiply by t. Of course, for this example, what is the direct logic we checked? Whenever the input or output is external function of time, automatically variant system. Whenever the input or output is external function of time, automatically it is a variant system. In this particular question, no mathematics is needed, sir. Whenever the input or output is external function of time, it is a variant system. Let us go to next example. Y of t equals to sine of xt. Now it is I or V, sir. Y of t equals to sine of xt. When you take input delay, directly x of t plus x of t minus t naught. Output delay also. When you take output delay, then also what is the result, sir? Same. So result is same means invariant system. Result is same. X square t system square. System is squared, sir. Due to input shift, what is the answer? First x of t minus t naught for that square. X of t minus t naught for that square. What is directly y of t minus t naught? That is also same expression. That is also same expression. So system is time invariant. Input delay or output delay result is same. x of t by 3. Now, sir, x of t by 3. What you can say? Now it is variant because due to input shift, what is the result? T by 3 minus T naught because xt is first shifted. Later on the system operation T place T by 3. Later on the system operation T place. Direct output shift is what? If you take direct output delay, answer is different. These two are not equal. So system is variant. In a similar way, if I ask for x of minus t, now you tell me. If I ask for x of minus t in a similar way, sir, time reversal operation, it is also variant because due to input delay, what is the result? Minus t naught. But output delay means x of t minus t naught. That is x minus t plus t naught. Results are not same, variant. So in general, time scaling is a variant operation. Alpha not equals to 1, sir. In this example, alpha 1 by 3, here alpha minus 1. In general, time scaling is a variant operation. I'm going to next slide. Yt equals to xt into cos omega naught t. Now, sir, every fellow can answer it. Any signal multiplied by sine or cos function is modulation. You are aware? Any signal multiplied by cos or sine function is modulation. Modulator is a variant system or not, sir? Modulation meaning is change of frequency. Due to input shift, what is the result? X of t minus t naught into cos function remains. Due to output shift, what is the result? Entire system shifted. So that becomes a variant system. Modulator, change of frequency, variant system. Differentiation of xt, d by dt xt, sir. Now you respond. Differentiator d by dt xt, IRV. Come on, bachas. What happened today? Response is very slow. Is it is amount of delay or you are sleeping? It is 100% invariant system, TI. Due to input delay, d by dt of x of t minus t naught. Output delay meanings are y of t minus t naught equals to d by d of t minus t naught x of course, dt naught is meaningless. Differential of constant is generally 0. Okay. Suppose you are failing this way. I mentioned with you, we can check graphically. What is the system operation we have, sir? Differentiator. Delay by 1 unit. Take opposite way. Delay by 1 unit followed by differentiator. If you apply common input, if the output graph is same, no problem. Suppose we applied ut as input. Differentiation of step is impulse. That is delayed by 1 unit means impulse existed once. U of t shifted by 1 unit. After that you perform differentiation. Still the impulse existed one only. So 100% invariant. Bachas. What is voltage across inductor formula? LdA by dt current through capacitor. CdV by dt, we are calling that expressions as linear time invariant system. We are calling that expressions as LTI system, standard. Correct or not? Differentiator is a invariant system. Okay. Let us take the next model. Suppose the input and output are described by an expression like this. I am giving two systems. Every fellow has to comment about linearity and time invariance of both the systems. Every fellow, upper system and lower system, comment on linearity and time invariance, two properties, everyone. Upper system respond. Is it linear or non-linear, time invariant or variant, upper one? Single fellow has not given correct. Funny fellows. Output is not only depending on input, external function of time is a time variant. Output is not only depending on input, external function of time, variants are. Linearity means we don't bother about time. So what is output versus input graph? Yt equals to xt means direct straight line, linear. First system, linear time variant. Lower system, there is no dependency on time, sir. So time invariant. But when you draw Yt versus xt, for positive inputs, output is equals to input, negative inputs, output 0. It is not forming complete straight line, non-linear. It is not forming complete straight line, non-linear. This year for electrical bachas, this question is asked as max of 0, xt. Means when input is maximum, output is maximum. 0 comma xt indicates that input amplitude starts from 0, which is indirectly this only. It is non-linear. Upper system has a time dependency, time variant. Lower system has amplitude dependency. Lower system has amplitude dependency, non-linear. Okay. Finally, some of you have given correct answer. Nothing new I discussed. I repeated the model. Upper system has time dependency, time variance. Lower system has amplitude dependency, so non-linear. If I give a differential equation, something like this, how you respond? dy t by dt plus ty t equals to x square t. I want both properties again. So what, Ravi? Yt may be 0 for negative time. But when you are checking amplitude, linearity means only amplitude. We don't bother about time. So 100% linear. Arey bacha, yesterday how we have drawn? Just recollect, sir. Output amplitude versus input amplitude, not time. So 100% it is linear only. This one, non-linear and time variant is the answer. Square is there, non-linear. Coefficient external function of time means time variant, sir. But if I change the same expression, something like this, d square yt by dt square plus 4yt equals to 3xt. If I change the same expression, something like this, then you think of now you comment. Very good. It is an LTI system because all coefficients are fixed. D square by dt square coefficient 1, yt coefficient 4, xt coefficient 3. Of course, no nonlinear element visible. No nonlinear element visible. Be careful. D square yt by dt square is linear element. Don't treat that as dyt by dt whole square, sir. This is non-linear element. This is linear element. Don't mix them. Okay. Right side quantity non-linear. Left side quantity linear. In any differential equation, if all coefficients are fixed only with linear elements, that is called as LTI system. Either you take differential or difference equations, sir. If all coefficients are fixed only with linear elements, that is an LTI system. In any differential equation, if all coefficients are fixed only with linear elements, it is an LTI system. Is a time invariant system, other name is fixed, or it can be also called as constant parameter network. Fixed means all the coefficients are fixed. Constant parameter means if you take RC RLC circuit with all fixed numbers, it can be treated as constant parameter network. So instead of an LTI system, They may use the word a linear fixed system. Fixed means all coefficients are fixed, sir. Fixed means all coefficients are fixed. Time invariant system is also called as fixed system. Another name, constant parameter. Yesterday we checked two nonlinear systems connected in series, may be linear. In parallel also may be linear. Now you think about two time variant systems connected in series. If two time variant systems are connected in series, is the overall system is invariant. We want to cascade two time variant blocks side by side. Is the overall system invariant is the question. What's that? Array, you are easy, bachas. You should give me the answer properly. Maybe invariant. Array, funny fellows. In communication, modulator is called as variant system or not, sir? Followed by demodulator, that is also variant system. Input M of t, output M of t. Input xt, output xt style. Modulator cascaded by demodulator. Input M of t, output also M of t. For this also you need thinking, bachas. Come on. Maybe invariant. Take compress by 2, sir. That is variant. Followed by expand by 2. That is also variant. If you give xt as input, here output is x of 2t. Final output is here x of 2 into t by 2. Means simply xt. Maybe invariant. Think about the parallel connection in a similar way. Parallel connection. Also you think about two time variant systems in parallel. Again, maybe, sir. Because if I take one system as xt plus t, it is not only depending on input function of another signal t. It is not only depending on xt input function of another signal t. Suppose we have taken another system like xt minus t, sir. Then also it is time variant. After doing addition, new system is what? That can be invariant or not. After doing addition, new system is invariant system. So either it is series connection or parallel connection, chance of invariance nature is there, sir. Either it is series connection or parallel connection. Okay. I'm moving to next slide. Some of you are working. Now only some 10 fellows have added. Suddenly. Okay. Study this question and answer me, sir. Consider an LTI system whose response to the input x1t is y1t. Find the response of the system due to other two inputs. System is named as LTI system. Acha, power gun and you came now. Okay, enjoy. For an LTI system, a rectangular input is producing triangular output, sir. It is expected find the output due to other two inputs. Generally, rectangular input becomes triangular output means possibility of integration generally. But there is no need to know what is the exact mathematical operation here, sir. The system name itself will tell the result for us. LTI, linearity and time invariance, means addition and shifting. What is LTI system property is whatever the relation holds good for input, same relation is equally true for output. You try to express the relation between x2t and x1t, automatically you will get the output, sir. Try to express the relation between x2t and x1t. x2t in terms of x1t is very easy. Upper rectangle is x1t, lower one is x1 of t minus 2 with negative amplitude. So x2 of t equals to x1t minus x1 of t minus 2. Upper one is x1t, lower one is x1 of t minus 2. Everyone see here, we have done addition, that is linearity. Second time shifting, sir. So what is LTI system property? Y2 of t is y1t minus y1 of t minus 2. Sorry. Whatever happens to input, same thing happens to output. Try to express the relation between input signals, we'll get relation between output signals. So this is y1t, sir. Y1 of t minus for an LTI system, whatever happens to input, same thing happens to output. Try to express the relation between inputs, we will get the relation between the respect to output, sir. Input signals added means output signals are also added. Input signals are shifted means output signals are also shifted. Now everyone try how to write x3t in terms of x1t. If possible, respond in the chat box. How to express x3t in terms of x1 of t. How to express x3t in terms of x1t. Akhil, check your result. Nitish, correct? Come on, come on. Compression you cannot do, ma. Because just now we stated compression is variant operation. But name of the system LTI system, you should not do compression or expansion or reversal. If you want to compress the signal, system must be also compressed. But just we know the name of the system as LTI. We don't know what is exact system. Come on, bachas, respond. Ayushi, correct. Akhil, correct. Very easy. Time scaling, time reversal also possible for this question. But they are wrong for this example because the system is LTI, sir. The simple thought you need is x3t starts at -1, x1t starts at 0. Try to add x1t with x1 of t plus 1. Take left shift such that the rectangle covers from minus 1 to 1, sir. Sum of these two is, of course, the resultant graph x3t. Minus 1 to 0, 1 plus 0, 1 unit, sir. 0 to 1, 1 plus 1 becomes 2, like that. So x3 of t equals to directly x1t plus x1t plus 1. x3t is x1t plus x1t plus 1. What is LTI system property? Same relation holds good for output y1t plus y1 of t plus 1. We should add two triangles now. y1t triangle covers from 0 to 2. y1 of t plus 1 covers from minus 1 to 1. Sum of these two is the resultant graph. So minus 1 to 0, this is a positive ramp retained as it is. 0 to 1 negative ramp added to positive ramp, that becomes constant, sir. 1 to 2 negative ramp as it is. For the interval 0 to 1, positive ramp added to negative ramp. After doing addition, it becomes a constant. So for an LTI system, same relation is applicable for input and output. That is, whatever happens to input, same thing happens to output. Same relation holds good for input and output. From now onwards, at least 20 times I will ask you this question, which is a very simple concept, sir. Previous slide, what we have done, input signals are added, shifted means output signal is also added, shifted. This slide also same thing. For an LTI system, whatever happens to input, same thing happens to output. Now you answer me the latest gate question on this property. Latest gate question, gate 21. The input and output of an LTI system is given. Instead of T, that fellow has denoted that as H symbol, system symbol as H. By applying a discrete impulse, we got this as output. For an input x to n, when you apply this as the second input, for an input x2 of n, the peak value of output y2 of n when passed through H, means when passed through system, is, what is the maximum value of output when you apply this as input to the system? Due to del n, we got this. Due to this, what is the output? And what is the maximum amplitude of output when it is passed through the system? Same LTI system property blindly. Whatever happens to input, same thing happens to output. Come on. Try to express the relation between inputs, sir. Then you will know relation between outputs. What is the maximum value of y2 of n when it is passed through that system? System is LTI. What number? Nitish correct. Akil correct. Akil Gajavalli correct. Wanted it is given as fill in the blank question. Rakesh Pawan correct. Karunakar correct. Anjana correct ma. Pirin Kumar. Sai Prashant good. Just find out the relation between the inputs are x2 of n is actually del n plus 2 del n minus 1. Already x1 n is del n only. So it becomes x1 n plus 2 times x1 of n minus 1. LTI system properties, whatever happens to input, same thing happens to output. Y1 n plus 2 times y1 of n minus 1. This is y1 of n. That must be added to y1 of n minus 1 means first right shift. Two times we want amplitude changed. After doing addition at 0, answer is 1. At 1, answer becomes 4. At 2, it changes to 5. At 3, it is. This is y2 of n. So what is the maximum value we got, sir? When it is passed through system is 5. Here in the shifting operation, you may do addition improperly. Be careful. What is that, Ayushi? I asked maximum value. The fellows who have attended my class already, they can cross-check whether I discussed the last problem in the class or not. For an LTI system, whatever happens to input, same thing happens to output. On the same property, question is framed, sir. You should get that idea. LTI system means whatever the relation holds good for input, same relation is equally true for output. That thought you need. Then only you can answer. And some of you have done mistake in shifting. That is the reason you have given a different amplitude. Be careful. Okay. That is about linearity and time invariance, both the system properties, sir. Let us go to next system. Causal and non-causal system. We define causal signal as a signal that is existing for positive time is causal signal, sir. Because it is system, it is relation between input time and output time. What is causality of a system condition is present output should not depend on future input. Suppose you are checking output at a particular instant T0, sir. Input may be taken at T0 or less than T0. It should not ask for any future value. Present output should not depend on future input. Suppose for a system, if you are checking output behavior at 5, input may be taken at 5 or less than 5. It should not ask for next instant like 6 or 7. Present output depends on future input means it is a non-causal system that we cannot design practically. The best example of non-causal system is without releasing movie saying that it is bumper hit. It may happen or may not happen. Without writing competitive exam saying that I will be in top 10. With respect to feeling, so many things are possible. Reality is different or not. So how to check causality of a system, sir? As the time varies from minus infinity to plus infinity, as the time varies from minus infinity to plus infinity, present output should depend only on present input and past inputs. Let me write the definition. A system is causal if present output depends on present input, past values of input, but not on future values. That is, causal systems are non-anticipative. Non-anticipation means they will never respond to future inputs. Causal systems are non-anticipative. They will never respond to future inputs. So we have to check this condition with respect to time. Parenthesis output time versus input time. Output time versus input time. Present output, present input, past input. Respond this example, causal or non-causal, 2t plus 3 into xt. Check the bracket term, parenthesis. Output time, input time, one same sir. Y0, x0, y1, x1, instant of time is same, causal. Check the bracket term, not the external multiplier. Output time versus input time, causal. This system again, output time, input time both are same means causal only. Output time, input time both are same, causal sir. Always check the parenthesis, output time versus input time bracket. Sin of xt, yt equals to sin of xt. Again, input time, output time are same. Instead of sin xt, if it is given as x of sin t, sir. Instead of sin xt, if it is given as x of sin t. Now you think there is a chance for non-causality now. Why sin t equals to 0 means the general solution is integer multiples of pi. So if you take output at minus pi, right side becomes input at. Present output requires future input. Output is taken at minus pi, but input is needed at 0. Of course, this example, it is not only minus pi, sir. Even if you take minus 2 pi instant, still we want the answer at 0. Present output asking for future input means non-causal. How we got the idea of pi? Because of sine function solution. Sine t general solution, we got that thought, sir. Okay, moving to next slide. Minus infinity to minus 3t x tau d tau. Minus infinity to minus 3t x tau d tau. The upper limit is clear indication for us. T place minus 3t is given. T place minus 3t. It means if you substitute any negative instant, after integrating the input till 3, we want the values. After integrating the inputs, you are taking output at minus 1, but input is needed till 3. Non-causal. Suppose our upper limit is just t, sir. If it is given as minus infinity to t, if the upper limit is just t, it is 100% causal. If you take minus infinity to t, then it is 100% causal. Now everyone respond. 2xn plus 3 u of n plus 2 discrete system. 2xn plus 3 u of n plus 2, sir. Respond. It is 100% causal system. Yn depends on xn. This is some extra signal. We don't bother about it. We stated present output should depend on present input, not on external signal. See the statement. A system is causal if the present output depends on present input and past values of the inputs are. We don't bother about the additional signals that are added. So it is a causal system. X of n square, yn equals to x of n square. It can be non-causal. If I substitute any negative index like minus 2, input is required at 4. So system is non-causal. Sigma n naught to n xk, n naught is finite. We are adding the samples of the input from n naught to n. N naught is finite, n may be any value. Now, sir, n naught to n naught is finite, n may be any value. It depends on n naught because n naught may be greater than n or less than n. Chance is there. for both. Suppose we have chosen a specific case like n naught greater than n, sir. For understanding purpose, I am taking 2 and 1. So what will happen to the expression y1 equals to sigma k equals to 2 to 1 xk. That is x2 plus x1. So we have taken output at 1, input is required for 2. N naught greater than n, non-causal. Other way. What is the meaning of other way? N naught less than or equals to n, it is causal, conditionally causal. Because based on n naught only we can say the answers are conditionally causal. When this type of model is asked, they will mention very clearly, sir, under what condition it is acting like causal or non-causal, conditionally causal. Suppose in the summation, if we make lower limit as 0, sir, instead of n naught, if you make lower limit as 0, then what will happen? Y of n equals to sigma 0 to n xk. Now you respond. Instead of n naught, we have made 0. It will be non-causal. Because positive index, we will not face any problem, sir. Negative index, what will happen? That becomes x0 plus x of minus 1. With respect to output at 1, you require the input at 0. Positive index, we are not facing any problem. Negative index failed. Non-causal. If you make lower limit as minus infinity, then what you can say? Instead of 0, if you take that as minus infinity, it can be causal because we are starting at initial index. It is actually called as accumulator addition. Suppose if you have taken n value 1, sir, minus infinity to 1 xk, etc. x minus 2 plus x minus 1 plus x0 plus x1. With respect to output at 1, all these are past inputs. This is present input. Present output is sum of past values of the input and present input, which is called as accumulation principle. 100% causal. Observe this point, everyone. I am adjusting this expression as sigma minus infinity to n minus 1 xk. Only the last sample I am writing separately, sir. N is the last value that I am writing separately. Before n, what we have? N minus 1. So with respect to system expression, it is y of n minus 1. If I replace n as n minus 1, upper limit becomes n minus 1 or not. Same summation formula is now modified as a difference equation, which is also causal system. See, we stated present output depends on present input, past input. Also past outputs, no problem. Because in this summation, if I take n minus 1, it becomes y of n minus 1 plus last sample extra. Present output depends on present input and past output. Still it is causal only. Still that system is causal. Now you think of 1 by 2m plus 1 sigma minus m2 plus m x of n minus k. Capital M is a finite number. Capital M is a finite number, sir. Is it causal or non-causal? The summation limits indicates it is non-causal. We are varying from minus m to plus m. For understanding purpose, assume m value 1. If we assume m value 1, what will happen to the system expressions are? Sigma minus 1 to 1 plus x of n minus k. So x of n plus 1, k0 means xn next to x of n minus 1. With respect to output at nth sample, this is next sample, non-causal. Don't say if m is 0. If m is 0, it is an identity system. What is the need of this build-up? This expression is called as moving average system. The samples are moving one by one, n plus 1, n minus 1. As we selected 3 samples, average 1 by 3. As we selected 3 samples, average is 1 by 3. Moving average system. %90 of the examples which we have given here are non-causal. 90%, sir. In the beginning only we said non-causal systems cannot be designed. Then what is the technique we are following to convert non-causal system to causal system means there are 2 techniques, sir. One is windowing approach. When you have infinite set of data, to make that as finite set of data, multiply with a window. That is called as FIR filter, finite impulse response filter. Another technique is time shifting. Assume if the data is available from -4 to +4, that is non-causal. If you cascade minimum 4 delays to the existing system, if you cascade minimum 4 delays, automatically it is causing right shift of 4 samples means new index 0 to 8, sir. -4 to 4 index, if you cascade minimum 4 delays, the new index becomes 0 to 8. So non-causal system can be converted to causal system. One technique we are following is windowing. Another technique is shifting. Non-causal systems cannot be designed when the independent variable is time. Non-causal systems cannot be designed when the independent variable is time. Time means continuous case T, discrete case N. But they are possible with spatial coordinates. Electrostatic potential E of x comma y comma z comma t, or image processing I of x comma y. With the spatial coordinates, they are possible because spatial coordinates are based on imagination. If I choose this pixel as x comma y, next one becomes x comma y plus 1, x comma y plus 2. There we are taking advanced element, but they are spatial coordinates. We are studying this subject with which coordinates are time. With respect to time, non-causal system is not possible. With respect to time, non-causal systems cannot be designed, sir. With respect to the independent variable as time. With respect to time, we cannot design non-causal system. Okay. Let us discuss the next system. Fourth one, static or memoryless or instantaneous. All have same meaning. Static, memoryless or instantaneous. Dynamic with memory. So what is the definition of static system is, if the input and output are observed at the same instant, then the system is static. If you are checking output at 5, sir, input is also taken at 5. If you are checking output at 9, input is also taken at 9. It should not ask for past or future values. So a system is static if input and output are observed at the same instant. T equals to T naught or N equals to. So the concept of static system is very simple. Learn now, forget now. No storage. It will take, it will give out. Okay. Let us verify a few examples here. E power minus 2t plus 3 into xt. Again, your job is checking parenthesis. Output time versus input time, sir. Static or dynamic now? Yt versus xt. 1 minute. देखो भवेश. Static or dynamic, sir? Input time, output time, both are one and same. Means static, memoryless. If you say 3xt plus 5, again input time, output time, they are one and same. Modulator. Yt equals to xt into cos omega naught t modulator. This is also memoryless. What about differentiator, sir? Any differential term is due to energy storing element. Rate of change means we are always taking with a gap. Any differential element is due to energy storing element. System is a dynamic. You know that examples, inductor and capacitor L and C are the energy storing elements. Are any differential term is due to energy storing element. System is dynamic. Ashish Kumar, don't create your own statements. X of t minus 5 is a time invariant dynamic. Okay? Don't create your own statements. Suppose I have given t into xt, that is variant but static. Don't do such things, sir. Y of n equals to g of n plus 3 times xn, a discrete system. Y of n equals to g of n plus 3 times xn. Again, what we are checking, sir? Output index versus input index. We don't bother about extra multiplier, static. X of 3n, jump, decimation. If I take output at 1, we need input at 3. First system, see here, first system is causal or non-causal, sir? This one. All, this is a causal system. This one also causal. Third one also causal. All static or memoryless systems are causal. All static or memoryless systems are causal, but not vice versa. Causality is not guaranteeing static nature. Accumulator is the best example, sir. All static systems are causal, but a causal system need not be static. I will show you here, bachas. See here, 12th slide. Accumulator, causal, but it is storing past amount of inputs, dynamic. Causality never guarantees static nature. Why we are saying static system as causal? Because causality also expects the same condition as static. Present output depends on present input. Extra past inputs also there. Extra. So once the system is static, automatically it is causal, sir. Once the system is static, automatically it is causal. All static or memoryless systems are causal. Wait for a while. D by dt xt is causal, ma Aishwarya. D by dt xt is causal system. Everyone respond this. Find whether the following systems are linear, time invariant, and dynamic. Of course, all 4 expressions are dynamic because differentiation is there, sir. All systems are dynamic. Let us discuss the other properties, linearity and time invariance. Each case, first time it is linear, time variant because of 2t, external function of time, linear, time variant, sir. Second expression, all coefficients are fixed with linear elements, LTI. Third one also LTI. All coefficients are fixed with linear elements. Last one, dyt by dt whole square is there, means non-linear. 2t yt, coefficient external function of time, means time variant. Dyt by dt whole square indicates non-linear, sir. Coefficient external function of time, time variant. First expression linear time variant. Second and third LTI. Last one non-linear time variant. Just be thorough with system properties. Then only you can answer this question. You must be thorough with system definition. Okay. Now you think of linearity, time invariance, static or dynamism is expected, sir. Difference equations are given. Previous problem differential, this is difference. Linearity, time invariance, static or dynamism expected. Y of n plus 2 plus yn plus 1 plus yn equals to 2 into x of n plus 1 plus xn means linear, time invariant, dynamic. All coefficients are fixed. Linear, time invariant, dynamic. Second one, square is there means non-linear, time variant, static. Instant of time is same. Yn, xn, instant of time is same. Last one, third one. Yn plus 1 plus nyn is 4 and xn means linear, time variant, dynamic. N and n plus 1 indicates dynamic. Last one, bachas. Y of n plus 1 into yn unknown signal product is which operation? Y of n plus 1 into yn unknown signal product is non-linear, time invariant, dynamic. Non-linear, time invariant, dynamic. Normally in competitive exams, they may give one system expression and ask for at least 2 or 3 properties. Or this is another style. System properties match the correct pair. If you are thorough with the system definitions only, you can answer such models. You must be thorough with definition of systems. Okay, let us go to next model. Please think of everyone. Consider the feedback system shown in figure. Assume output is 0 for negative index. Summing point followed by unit delay. Find the output when you apply input as del n as well as un. First time when you apply discrete impulse, what is the output? Get the system expression, sir. What is the relation between yn and xn? Get it? Then you will get the answer. Find out the relation between input and output. Unit delay means delay by one sample. Try to express the relation between input and output. Then only you will know the answer. X and Y and relation you obtain. If I assume a middle variable E of an output of summing point as En, output is feedback with unity gain. So En equals to Xn minus Yn. Of course, Y of N is E of N minus 1. Remove the middle variable. That is X of N minus 1 minus Y of the present output depends on past input and past output, sir. It is stated output is 0 for negative index. First time, what is the input we applied, sir? Del n. Start from 0 to solve the difference equation. Y0 is x minus 1 minus y minus 1. Of course, both values 0. N equals to 1 means x0 minus y0. Input at 0, 1, sir. Output at 0 is 0. N value 2 means y2 is x1 minus input at 1 is 0. Like that, we have to continue the enjoyment. Output is feedback to input means it leads to oscillations. Output amplitude oscillates between 1 and minus 1. Output amplitude oscillates between 1 and minus 1. First sample we got 0. Rest of the samples are 1 and minus 1. First you obtain the difference equation. What is the relation between input and output? It is described by that expression, sir. After that, because it is mentioned output is 0 for negative index, start solving from 0. First sample we got 0, rest of the samples alternation of impulses 1 minus 1, 1 minus 1 like that. But if this question is asked, directly get the output at 50th sample. By giving the same problem, if it is expected, get the output at 50th sample, sir. You cannot do all the stupid maths, which is quite lengthy. Further, the transform domain makes the difference. Transform domain means jet transform. Unit delay is represented as Z inverse. Unit delay is represented as Z inverse. It is a negative feedback system, means G and H controls. What is the logic? G by 1 plus GH. I am solving in the next slide, sir. What is the alternative way of answering this question is, if you feel this as G, this as H, the transfer function becomes what? Z inverse by 1 plus Z inverse is the transfer function of the corresponding system. G by 1 plus GH. Input impulse means impulse jet transform. Impulse jet transform is 1. We got output jet transform. Output jet transform is input jet transform multiplied by transfer function. Transfer function is this, sir. Of course, to write the inverse, we have predefined formulas in Z domain. A power n un is having jet transform as this. X of n minus n naught time shifting property z power minus n naught xz. Just listen. Even you are not having an idea, just listen. So 1 by 1 plus z inverse is looking like 1 by 1 minus a z inverse. Standard formula a power n un. 1 by 1 minus a z inverse forms are. Extra z inverse indicate one sample of shift. So this answer is minus 1 whole power n minus 1 after 1. Because of u of n minus 1, it is after 1. Automatically output at 0 is 0. That we know in the last slide only. What is output at 1, sir? If I substitute n plus 0, 1 minus 1 whole power 0, 1, we got that result. Similarly, what is the output at 50? Minus 1 whole power 50 minus 1 means minus 1 is the answer. What is the advantage of transform domain? With the background of these formulas, in 2 steps we completed it. First, you have to solve for transfer function GH, G by 1 plus GH, input jet transform, impulse jet transform, one side. Based on these 2 formulas, we have written the inverse. Directly, we got the result. So, time domain analysis is difficult even to solve a first order system expression. We have solved only first order system. Even for first order system expression, it is difficult. Transform domain, it is easy. Okay. I have given one more input here. Try for it. Second input we applied is unit step sequencer. You should get the answer at 0, 1, 0, 1 like that. 0, 1, 0, 1 like that. So to solve this problem in easy manner, this is one technique. And one more point to be observed in our discussion is either you apply del n or un, output has how many number of samples are? Either you apply del n or un, output contains how many number of samples? Infinite number of samples. So this expression is called as IIR filter, infinite impulse response filter. The expression is called as IIR filter, infinite impulse response, because output length is infinite number of samples. What is the difference between FIR system and IIR system is, if our present output is function of present input, past inputs only, it is finite impulse response filter. No feedback will be there. If it is also depends on past outputs. What is the meaning of past outputs? Yn minus 1, Yn minus 2 like that. Then it is treated as IIR filter. Only combination of inputs FIRs are. It is also depending on past outputs, IIR. IIR filters are implemented recursively, but FIR filters are implemented only non-recursively, no feedback. In controls, it is like open loop, closed loop. FIR system is like open loop. IIR system is like closed loop. Only combination of inputs is finite impulse response. If it also extra depends on past outputs, it is IIR system. Normally in ESC, this type of funny questions are also asked. Which of the following expression corresponds to IIR? Then what you have to observe, sir? Whether present output depends on past output or not. FIR filter has no feedback, non-recursive systems. IIR filter can be implemented both ways, recursively, non-recursively. Okay, the purpose of choosing this problem is time domain, we have to solve sample by samples, very lengthy. Transform domain with this background, obtaining the answer is very easy. But what we need is being thorough with these relations, sir. Jet transform relations that we are learning in the future. Okay. The next concept which we are learning is stability. Stable and unstable system. The concept of stability is linked to boundedness. The concept of stability is linked to boundedness. Boundedness represents the absolute value or maximum amplitude of the signal. We are speaking with amplitude here, sir. Boundedness represents the absolute value or maximum amplitude of signal. Time domain, we are calling stability condition as BIBO. Bounded input, bounded output. What does it mean? If you take a continuous time system, if input is xt, output is y of t, sir. What is the mathematical way of saying BIBO is? If the absolute value of input is taken as finite number mx less than infinity, if maximum amplitude of input is taken as a number like mx, what is mx? 2, 5, 10, 100, any number you take, it must be less than infinity. Then for that system, if we try to make magnitude of output also finite, then it is stable, otherwise it is unstable. Try to apply an input signal that is maintaining finite amplitude level. If output also maintains finite amplitude level, system is stable. So the correct way of giving definition is like this, sir. A system is stable if for every bounded input there exists bounded output. A system is stable if for every bounded input there exists bounded output. According to the standard signals we studied, which are the bounded inputs are UT bounded, no problem. Signal may be infinite length, finite amplitude of 1. Signal may be infinite length, finite amplitude of 1. Continuous impulse is bounded. Continuous impulse, no, because it has infinite amplitude. RAM signal bounded. No. What about cos and sine function? Of course, they are bounded. Amplitude variation of plus or minus 1, answer is 1. So continuous case, which are the bounded inputs are UT, cos and sine. Discrete case, both the standard signals are maintaining finite amplitude. Del an amplitude 1, U of an amplitude also 1. Both are maintaining finite amplitude. Don't apply RAM signal as input and say system is unstable, sir. That is wrong. Okay. Like we checked linearity condition, stability is also linked to output amplitude versus input amplitude. A system is stable if for every bounded input there exists bounded output. Please go through it, everyone. We are using the word marginal stability, that is in S-plane. When you learn control system, what is the margin there? J omega x is margin. In time domain, there is no margin, sir. Time domain stability is BIBO, bounded input, bounded output. So continuous case, which are the bounded inputs we can apply? UT, cos and sine. Any system, for every bounded input, it has to produce bounded output, sir. If it is failed for step function, means automatically unstable. If the condition fails for step function, means automatically unstable. For every bounded input, there exists bounded output is the condition. Okay, let us take some examples here. Yt equals to x square t, system is squarer. Stable or unstable? Yes or yo? Only type that yes or yo. Y of t equals to x square t. Yes or user. Answer is stable. If you apply ut as input, output becomes square of step function, of course. 1 whole square is one step function itself. Or if you apply cos, yt becomes cos square theta finite because it is 1 plus cos 2 theta by 2. Or if you apply sine functions, yt becomes sine square theta, of course, 1 minus cos 2 theta by 2. For every bounded input, there exists bounded output, stable, 100% stable. Input amplitude finite, output amplitude also finite, stable. Don't think about y equals to x square karo bachas. Stability means output amplitude versus input amplitude. It is not time. Even at infinite time, if output amplitude is finite, system stable, sir. The alternative way of answering this is simply take modulus both sides for the system expression. Mod yt is mod xt whole square. Our definite requirement is mod xt must be finite. Don't apply any input but assume finite, sir. Finite quantity whole square is finite. System is stable. With input you can check, without input also you can check. Mod xt finite, finite quantity whole square is finite, system is stable. Now you think of, sir, t into xt, stable or unstable, t into xt. If you apply ut, which is a bounded input, output becomes ramp unbounded, jump. Bounded input is producing unbounded, output unstable. Differentiators are d by dt xt, differentiator. d by dt xt. When you apply ut bounded input, differentiation of step function is impulse, that is unbounded. So unstable. But if you apply cos or sine function in this example, we feel stable or not, sir? In this particular case, if you apply cos or sine function, we may feel finite amplitude level, but it is failed for step function. In general, in any differential equation, if input derivative is more than output derivative, system is unstable, sir. In any differential equation, if input derivative is more than output derivative, system is unstable. In this example, derivative of input first order, Output no derivative, 0th order. If input derivative more than output derivative, system is unstable. Integrator, sir. System is an integration. Stable or unstable? Integration of step is RAM, unbounded. You are trying to give a bounded input, but you got unbounded output. Bounded input is giving unbounded output. System is unstable. Everyone comment on modulator. Simple example, xt into cos. Modulator. Stable or unstable? Modulus of yt equals to modulus of xt into modulus of cos. Mod AB styles are right side. Of course, absolute value of cos is 1 maximum. Our definite requirement mod xt must be finite. Absolute value of cos is 1, mod xt finite means mod yt finite. System stable. System is stable. E power xn, a discrete system. Now you respond. E power xn. Yes or yo? Very good. Most of you have given correct answer. Stable system. Modulus of yn equals to e power modulus of xn. Of course, magnitude of input must be finite, sir. E power finite value is 100%. Finite system is stable. Don't have a wrong thought of e power x curve. This is not time axis. Output amplitude versus input amplitude. As long as input is finite, output is also maintaining finite amplitude. Input cannot be infinity. So 100% stable system. 100% stable. As long as input amplitude finite, output amplitude also finite. I am repeating the system which I have given for you at causality. Sigma n0 to n xk, n0 is finite. Now you tell me. Sigma n0 to n xk, n0 is finite. We want to add the samples of the input from n0 to n, sir. N may be any value, n0 is finite number. Stable or unstable? Bachas, without solving, don't give the answer. Just like that. To solve summations for stability in easy manner, technique is assume input amplitude 1, N naught also 1, sir. Assume input amplitude 1, N naught 1. Such that what will happen to the system? Sigma k equals to 1 to N1. If I assume input amplitude 1, N naught 1, sigma k equals to 1 to 1 plus 1 plus 1, like that n terms are there. So answer is N. What is the graph of N, sir? Instant of time is respect to amplitude, which is neatly looking like unbounded graph. As n tends to infinity, amplitude of output is tending to infinity, unstable. Don't ask a stupid question. If n is infinity, why you are saying n is infinity? What is the target for stability? Even at infinite time, output should maintain finite amplitude. We applied a bounded input because input amplitude 1, but we got unbounded output graph. Unstable system. Same summation, I am changing limits, answer me. Only I have changed limits. Think of and respond. Sigma n minus n naught to n plus n naught xk. N naught is finite. Follow similar techniques, sir. Assume input amplitude finite, n naught finite, like previous problem. Then you can comment. Stable or unstable, bachas? I am following same technique. Xk is 1 and naught is 1. What will happen then? Sigma k equals to n minus 1 to n plus 1, 1. So 1 added 3 times. Because n minus 1 to n plus 1 means I have 3 samples, 3 index are. Amplitude becomes 3, finite. Actually, in the question, if I assume n naught as 1, we got 3, sir. If I assume n naught as 2, summation limits are n minus 2 to n plus 2. If I assume n naught as 2, n minus 2 to n plus 2, then it becomes 5. In terms of n naught only, answer is 2n naught plus 1. If you want the answer directly in terms of n naught, 2n naught plus 1. As it is stated, n naught is finite. System is stable. So what I have done in the last 2 examples, whenever summation problems are given, to get the stability or to check the stability in easy manner, what we have to do? Assume input amplitude and n naught finite numbers. Easy numbers both are 1. Assume 1, you will get the result. Okay. By assuming 1, we are getting easy results, sir. Okay, take break for 20 minutes. We'll continue again. The last system, invertibility. Take break for 20 minutes, sir. Jyotisha, this is a habituated background. We can't change, ma. Okay. Generally, white background is very good when we are writing. Okay. The last concept which we learned is stability, which is linked to boundedness concept. Let us discuss the last form of system. That is the sixth one. Invertible and inverse system. Invertible and inverse system. What is the concept of invertibility is, for a given system, if we apply different inputs having different amplitudes, for a given system, if we apply different inputs having different amplitudes, in the sense, if we apply ut and minus ut, they are considered to be different inputs only. Or if you apply 3, 4, 5 constant of different amplitudes, then also they are different. For a given system, if you apply different input signals having different amplitude levels, if the output is also different, then the system is invertible. Otherwise, it is non-invertible. Indirectly, two different inputs should not produce same output. When you apply ut and minus ut, if you got output as same, sir, that is a non-invertible system. Okay. So the definition is like this. A system is invertible if different inputs, in the sense having different amplitudes, leads to different outputs. That is, two different inputs for a given system should not produce same output. Two different inputs for a given system should not produce same output. We define system as a T for transformation. So the inverse block is denoted as a T inverse. Input xt, output is transformation of xt, but output of second block is simply xt, because T into T inverse represents an identity operator. Both the systems are opposite to each other. Where we require this invertibility concepts are entire communication, signal transmission. Once we apply some form of input, because of the internal component, it may get distorted. Once we apply some form of input, because of the internal component, it may get distorted. To cancel the distortion, we are using inverse block called as equalizer. In communication, we are studying different forms of equalizers or not. To avoid ISI intersymbol interference, raised cosine filter, zero forcing equalizer. So whatever the distortion that is introduced in the channel, to undo that effect, we are designing inverse block, which is called as equalization technique. Like linearity and stability, this system also has amplitude dependencies. One time you apply positive amplitude, another time you apply negative amplitude. If the output is same, system is non-invertible. For a non-invertible system, inverse is not unique. If the system is invertible, then only inverse is unique, sir. For a non-invertible system, inverse is not unique. So we can say a system is invertible if we can uniquely determine the input by observing the output. A system is invertible if we can uniquely determine the input by observing the output. Just go through the definitions here. We'll solve few examples related to it. Okay, let us discuss few examples here. Yt equals to x square t. Is it invertible or non-invertible? I or Ni? Invertible or non-invertible? What happens if you apply input as ut or minus ut, sir? Either you apply input as ut or minus ut, what is the respective output? Square of step function is step function itself. Or suppose I applied 3 or minus 3, we got same output 9. So system is non-invertible. We change the amplitude of input, but output is same. The other way of saying this point is, what is x of t result in terms of y of t, sir? Plus or minus root yt. If you want to write xt in terms of yt, plus or minus root yt. Is plus root yt is correct or minus root yt is correct? We can't say. We have a sign ambiguity problem. Both solutions are correct. If it is invertible, inverse is unique, sir. If it is invertible system, inverse is unique. Y of t equals to cos of xt. Now, sir, because of the periodicity of cosine function, we can say it is non-invertible because of the periodicity. Because cos 2 pi answer 1, cos 4 pi answer 1, cos 6 pi also answer is 1. So it is non-invertible. Because of the periodicity of cosine function, it becomes non-invertible. If I give u of xt, similar way, if I give u of xt, what is u of xt mathematical form we have written, sir? 1 for xt greater than 0, 0 for xt. So you take any change in positive amplitude of input. What is the fixed output we have? 1 negative inputs, it is 0. Either you take input as 1, 2, 3, 4, any number. The fixed output is 1. That indicates system is non-invertible. Non-invertible. d by dt xt differentiator. d by dt xt. Differentiation of any constant number means what is the result, sir? Differentiation of any constant is 0. Means it is non-invertible. You try to differentiate any constant value, result becomes 0. Non-invertible. What about delay? Delay by 5 units. Last example, we stated differentiation of constant, any constant. Constant means I may choose 2, another fellow 5, another fellow 10. Differentiation of any constant is 0. We are changing amplitude of input, but output is same, sir, non-invertible. What about shifting? X of t minus 5, input shifted by 5 units. It is invertible. If it is non-invertible, you should give me 2 inputs where the output answer you feel like same, sir. It is invertible. Ut becomes u of t minus 5 minus ut becomes minus u of t minus 5. If I give constant 2 for all time, of course it is also 2 for all time. As you are changing the input, respect to output is also changing, sir. Nowhere the result is same. Invertible. So what is the inverse of the corresponding system, sir? Look at the system expression, recover back xt. If you want to recover back xt, t is replaced as what? By looking at the system expression, if you want to recover x of t, t is replaced as t plus 5 in the output. Original system delay by 5 units. Opposite system advance by 5 units. Original system delay by 5 units. Opposite system advance by 5 units. Invertible. What about this discrete system, sir? N into xn. Discrete. Discrete case, the standard inputs are del n and un. Del n and un. When you apply input as del n, n into del n means 0 into del n, product property of impulse. When you apply product property of impulse, n into del n means 0 into del n. If you apply minus del n also, output is 0. So system is what? Non-invertible. We applied input with change in amplitude, but output is 0. Non-invertible. Input signal multiplied by its delay. Xn into x of n minus 3. Input signal multiplied by its delay. Simple example. What is multiplication of two positive numbers? If you are multiplying two positive numbers, what is the answer, sir? Positive. Two negative numbers also positive. So invertible or non-invertible? It becomes non-invertible. If we apply del n or minus del n, in both cases the fixed output is 0. Why? Del n occurs at origin, del of n minus 3 occurs at 3, sir. What is the product of them? No overlap. Multiplication of two positive numbers or two negative numbers is positive. That means non-invertible. Okay. I'm moving to next slide. yn equals to x of n into sine 5 pi by 6n. Signal multiplied by sine term. Now you respond, sir. I or ni? Invertible or non-invertible? When you try to apply input as del n, the output becomes del n into sine 5 pi by 6n. So impulse existed 0, sine 0 is 0. Product property again, impulse existed 0, sine 0, 0. Minus del n also answer is same. So non-invertible. Actually think in communication perspective, sir. If you think in communication perspective, signal multiplied by sine or cos means modulation. For doing demodulation, we are using multiple procedures or not? Coherent detection, non-coherent detection, like that. From the modulator to recover back original message signal, demodulation is not unique. We have coherent detection, non-coherent detection, like that. Okay. So that way also we can say it is non-invertible. One plus minus one whole power n xn. The system expression is given like this: 1 plus minus 1 whole power n xn. That is invertible or non-invertible? Actually, in the question statement only he has given hint. Only for even index, what is the answer, sir? 2 times xn. But for odd index, what is the answer? 0. It means if I apply any odd sample of input with change in amplitude, I am taking odd index samples with plus 1, minus 1, but what is the fixed output we have? 0. So system is non-invertible. We changed input amplitude, but output amplitude is same. Non-invertible. I hope this every fellow will answer x of 2n. X of 2n meaning is decimation. We studied a theoretical statement on this. Inverse of interpolation is decimation, but converse statement need not be true. Inverse of interpolation is decimation, but converse statement need not be true because we have zero interpolation, step interpolation, linear interpolation, like that, sir. If you have taken input numbers like 1, 2, 3, 4, another input like 1, 1, 3, 5, we change an amplitude of input, but after decimation, both are producing the same output. Without solving, we have a direct logic. What is the direct logic, sir? Inverse of interpolation is decimation, but converse statement need not be true. Reverse way statement need not be true. So out of the 6 systems we have learned till now, which systems have amplitude dependency means linearity, stability, invertibility. Other 3 systems have which dependencies are? Other 3 systems have only time dependency. Out of the 6 systems we have learned, 3 systems have amplitude dependency, 3 systems have time dependency. Let us discuss one miscellaneous concept which is called as doublet. It is not omelette, doublet. Derivative of impulse delta dash t. Delta dash t, derivative of impulse function. If you take one more derivative, it is called as triplet, sir. How we have chance of generating higher derivatives for impulse means by approximating a unit area rectangular function we observed, we can generate unit impulse. By approximating that standard signal's derivatives, we have chance of generating doublet. Just listen first, everyone. Suppose I have taken a unit area triangular pulsar. Its area 1/2 base height. Of course, here the slope is 1 by tau square. Here slope is minus 1 by tau square. For performing differentiation, I am using the slopes. If I go on reduce the width of the time axis, height is continuously rising. As the tau decreases, 1 by tau further increases. So for a negligible tau, it will appear like impulse graph. For a negligible tau, it will appear like impulse graph. What is the differentiation of this function, sir? Differentiation of positive ramp is positive step. Differentiation of negative ramp is negative. Try to do the same approximation here also. Go on, reduce the width of the time axis. Height will grow. Go on, reduce the width of the time axis. For a negligible time, this graph is approaching like the shapes are. Don't feel upper one is positive impulse, lower one is negative impulse. They cancel each other. This is the mathematical representation of doublet. By approximating a unit area triangular function, we can generate unit impulse. In a similar manner, by approximating the derivative of the triangle, we can produce doublet. Normally, voltage across inductor is LdA by dt or not. If I apply impulsive current source, then the voltage across inductor becomes differentiation of impulse. It is like dipole in EMTL, like dipole doublet. First of all, generation of continuous impulse itself is not possible, sir, because impulse means sudden change. But now we are expecting what? d by dt means rate of change of sudden change. Sudden change only overaction. For that rate of change, who will recognize? We cannot recognize. But we observed the mathematical properties of impulse function is making our solutions easy. Like area under unit impulse function we considered as 1. In a similar way here, area under doublet becomes 0 because doublet is a odd function. From the graph it is neatly visible, sir. Area under doublet function becomes, there we have taken scaling property like 1 by mod alpha del t. Here also we can use scaling property delta dash of alpha t is 1 by alpha into mod alpha delta dash. Main enjoyment sampling properties are integral xt into del of t minus t naught. What is the answer we have written is x of t naught shift should lie within the limits. The same property can be extended to derivatives also. Xt into del power n of t minus t naught, where n is the order of differentiation, sir. You can write on the right side minus 1 whole power n d power n by dt power n of x of t checked at t equals to t naught. How to observe the correctness of this result is assume no derivative, that will regain this formula. If you take n plus 0, that will giving back this formula. So the sampling property of impulse can be extended to the derivatives also. That is the reason we feel possibility of doublet. What is the possibility of triplet delta double dash T? You ask Fermi Dirac, he will tell you, because he is the inventor of that. Very clearly, sudden change only we cannot recognize, sir. Rate of sudden change means meaningless. But the mathematical property of impulse function has made our concept simple, which can be extended to derivatives also. Just go through it. By approximating a unit area triangular function, we generated unit impulse. By approximating a unit area triangular function, we generated unit impulse. By approximating the derivative of the triangle, we can produce doublet. By approximating the derivative of the triangle, we can produce doublet. Delta dash T. As doublet is looking like odd function, area under doublet is 0. As doublet is looking like odd function, area under doublet is 0. Okay, in the next slide, I have given properties for you, different properties. Suppose a question is asked like this, sir. What is the value of this integral, which is linked to doublet? Because it is first derivative minus 1 whole power 1 d by dt of that Gaussian function observed at the shift. Directly using this property, minus 1 whole power 1 d by dt of e power minus 3t square observed at t equals to 10. It is a miscellaneous topic. Don't take serious about it. Only in TAFR, Tata Institute of Fundamental Research, and ESC, they may frame some questions related to this. Yes, Vijay Bhaskar Reddy. Product property is equally valid in frequency domain. I will use it in coming classes. X omega into del of omega minus omega naught, like that. I will use it when I am explaining Fourier transform chapter. It is equally correct there. Okay. I'm moving to next slide. Actually, entire signal subject, we need some standard mathematical formulas, standard integrals. So which are the standard integrals we require in this subject? Means these are the standard integrals and summations which we are going to use when we solve convolution problem, Fourier series problem. What is integral sin x, integral cos x? So don't look at my face when that integral comes. It is your job. Okay. Somewhere we require these integrals, like suppose area under Gaussian function we used as direct formula under energy power signal root pi by a. That is one predefined relation, like that. If I start from 0 to infinity, 1 by 2 because of evenness, like that. So Whatever we discussed till now is introduction to signals and system. Let us start the fresh topic, convolution, that is LTI system. So the next topic is linear time invariant or linear shift invariant system. For 10 minutes, everyone listen the introduction. LTI system. Even we studied total 6 forms of systems. What is the reason only linearity, time invariance are given a special significance means most of the electrical networks, suppose we have chosen a RLC circuit, sir, with some fixed elements. Either you design an RLC circuit that will form a second order differential equation with all components fixed, or you go for spring mass damper with a standard automobile suspension system MBK with all fixed elements. Either you design an electrical network or mechanical system, blindly they are satisfying linearity and time invariance. That is one reason we are taking that as separate classification. Another reason, for any type of system we are giving multiple inputs and we are expecting multiple outputs. Sum of input signals should produce a sum of output signals. The concept of sum is linked to linearity. Output may be shifted version of the input. That concept is based on time invariance. Because of these two reasons, LTI system is taken as separate classification. One reason, either we design an electrical network or mechanical system, they are obeying linearity and time invariance. Output signals are taken as sum of input. When you take sum of inputs, it is producing sum of outputs, which is linked to superposition. Output may be shifted version of the input, that is linked to time invariance condition. The first point in LTI system is always described with respect to impulse response. What is the meaning of the word impulse response is when you apply input as xn, output is written as y of n equals to transformation of xn. When you apply input as del n, sir, whatever the output we are getting, that is called as impulse response. Impulse is the input means impulse response is the output. Step function is the input means step response is the output. So whatever the input we are applying, for that response is the tag attached. Impulse is the input means impulse response is the output. But we have to check why LTI system is named only as impulse response. Why we are not calling that as step response or ramp response? That reason we are checking now. Suno, dhyan se suno. Listen very carefully. Del n is the input means output is hn, sir. Del of n minus k means output is what? H of n minus k time invariance condition. Xk multiplied by del of n minus k means output is also multiplied by xk. That is, of course, our scaling principle, sir. If I am taking summation on the left side, right side also, we are taking another summation. That is called as additivity. Additivity and scaling, they are combinedly called as linearity. Additivity and scaling combinedly called as linearity. Other property, time invariance. Of course, that is the topic name, sir. This left side expression is called as the input expression named as shifting property. Right side expression is called as output, which is the definition of convolution. Left side expression is shifting property, sir. Right side expression is convolution. Actually, what is this stupid mathematical formula says is shifting property states that you can write any signal as sum of impulses. Shifting property states that you can write any signal as sum of impulses. How it is correct? Let me explain. Suppose if I have taken a particular signal like this, how many samples it contain? This example, it has 4 impulses. If I write x minus 1 into del of n plus 1, I am choosing the sample that is occurring at minus 1. It's not a big deal. K place minus 1. X minus 1 into del of n plus 1 means K place minus 1. What happens if I take K place zeros are in the formula? X0 into del n. At 0, the answer is 2. X1 into del of n minus 1. At 1, the answer is 1. X2 into del of n minus 2. At 2, the answer is what? Minus 1. If you try to add these 4 impulses, we have chance of recovering back our original signal or not. So in this problem, K ranges from minus 1 to 2, sir. In this problem, in general, K ranges for minus infinity to infinity. As a shifting property states that you can write any signal as sum of impulses. If you denote the black box, which we are calling as LTI system, you apply any form of input, it will cut the signal into pieces. What pieces? Impulses. Internally, it will find the output due to every impulse. Internally, it will find the output due to every impulse. What is happening internal to the system, no one knows. That we are checking by using a tool called as convolution. So the basic idea of convolution is when you apply some form of input to system, how the output graph is changing, that we can check graphically or mathematically. Because what is happening internal to the system, no one knows, sir. But that we can check mathematically or graphically by using convolution tool. So if anyone asks you why an LTI system is represented as impulse response means, what is the answer you have to say, sir? According to shifting property, we can write any signal as sum of impulses. Any signal as sum of impulses, because of which LTI system is denoted as impulse response. Let me give a rough idea for the word convolution. What convolution will do? What convolution will do? Suppose, for your easy understanding, a simple example I am giving. If I place a particular mass on a flat surface, the input to this is hitting the mass continuously with a hammer. You feel this like hammer. Hitting the mass continuously with a hammer. At every impulse you hit, you want to draw what is velocity versus time graph, sir. If I make one hit, slightly the mass will go to a new position T0. Assume due to that impulse you hit, you got this as the output. If I take one more hit, slightly it will go to a new position T1. Assume the output is like this, H of T1. If I take one more hit, sir, it will go to a new position T2. Assume the output is like this. Like that, if I conduct that experiment for 5 minutes, within 5 minutes capacity, within 5 minutes, you may make 100 hits depending on your capacity. 100 hits means 100 impulsive hits. 100 hits means 100 impulsive hits. The superposition of all these impulse responses may form a new graph like this. This is the complete graph. So this complete graph is mathematically obtained by using a tool that is called as convolution tool. Actually, we are finding the output due to every impulse you hit. Superposition means addition. The addition of all these impulse responses form a new curve like this. That is what? Complete output graph that we are checking mathematically by using convolution tool. So two things you have to remember here. First point, an LTI system is always represented with respect to impulse response. What is impulse response meaning, sir? If input is impulse, output is impulse response. That is one statement. Second statement, shifting property states that, I will show the last slide straight. Shifting property states that any signal can be produced as combination of impulses. Shifting property states that any signal can be produced as combination of impulses. Of course, that is what we proved this example or not. Here I selected x of n for 4 samples, which is actually sum of 4 individual impulses. Last point, by using convolution, we are finding zero state response. State means initial condition. Zero state means all initial conditions are zero for a given input and system. By using convolution, we are finding the zero state response for a given input and system. Roughly, I explained here how the convolution is done, that we have to check now, sir. Why we got impulse response word means because of shifting property. Please go through the slides, everyone. This is the first slide of LTI system. Be attentive in the class, sir. Always. जीवन में सफल होना है तो अनुशासन होना है. अनुशासन बोले तो क्या है? डिसिप्लिन. When you have discipline, life will go very smoothly. Of course, some of you may be attending morning and evening session, but we have to do it. There is no other chance. Otherwise, you have to come to offline. So take care of your eyes also. So roughly I explained how we got convolution relation. Roughly. We got convolution because of shifting property only. As shifting property states that any signal can be produced as sum of impulses. We are denoting LTI system as impulse responser. I am moving to next slide. Just go through it. Shifting property. Here I explained any signal can be produced as sum of individual impulses. Okay, this is a rough example. Don't take serious about it, sir. Once we solve the models, you will understand it. Okay. Okay, these are the theoretical conditions which we have to remember in the chapter. Actually, one funny thing you should observe, everyone is superposition of impulses has given the thought of how to do convolution. Superposition of sine term, cos term, and complex sinusoids. They have given an idea of Fourier series and Fourier transform. Superposition of complex exponential. First class we studied e power st z power n. Of course, in Z transform, they have given the idea of how to perform Laplace and Z transform. So every chapter we are doing addition. Convolution means till we complete this chapter, what is the thought you need? We want to write every signal as sum of impulses. We want to write every signal as sum of impulses. When you go to Fourier series chapter, sir, what is the idea you need there? What is the idea? We want to write every signal as sum of sine term and cos term. When we go to Laplace, what is the thought you need? We want to write signal as sum of complex exponential e power st. Z transform, Z power n, like that. So all mathematical operations we are performing in the subject are linear because we are doing addition. Chapter to chapter, what we are adding means signals differs. Convolution chapter, what we are adding? We are doing convolution means indirectly a signal is expressed as sum of impulses that we should feel. A signal is expressed as sum of impulses. First, we are discussing continuous convolution examples. Later on, we'll shift to discrete forms. For your understanding purpose, first 2-3 problems I will explain graphical method, general method I will explain. After that, I will use mathematical tricks. Please go back to 30th slide. In 30th slide, we proved this is discrete convolution formula sigma xk h of n minus k. How it is modified in continuous batches? Recollect everyone. Summation is integration. The variable k becomes tau. N is replaced as t. Summation becomes integration. K becomes tau. N is replaced as t. So first let us discuss some examples on continuous convolution, sir. From now onwards, the name of the system is LTI system, which is denoted as h of t, input x of t, output y of t. Yt equals to xt convolved h of t. The star operation denotes convolution symbols. Star operation denotes convolution symbol. That is given by two styles. Integral x of tau h of t minus tau d tau, one formula, or the other way, x of t minus tau h tau d tau. Convolution is commutative, like AB equals to BA, xt convolved ht is ht convolved xt. That is the reason both are valid relations. Both formulas are correct one. Actually, what are the sequence of steps to be followed means in convolution, depending on your convenience, you have to fold any one signal, sir. Either h minus 2 or x minus 2, depending on the convenience. Later on, the folded signal is shifted. Then we are multiplying with other signals. So third step is multiplication. Fourth step is integration. Depending on our convenience, any one signal is folded. Later on, that respective signal is shifted. Multiply with other signal x2, find the area under that curve, that is called as integration. By following this 4-step procedure, we are in a position to get the overlap of two signals. Let me explain convolution in easy manner with a polynomial example. First, I am explaining an easy example to understand graphical method. Suppose if you have selected two polynomials like this, s square plus 2s plus 1 is one polynomial, s square plus 3s plus 4 is another polynomial. Normally, how to get product of these two, every one of you know the technique. First, we will multiply by s square some result. Next, multiply by 3s, shift the result right by 1 unit like that. But let us get this product by following convolution steps. Try to get this product by following convolution steps. In convolution, one signal remains same, the other signal is folded and shifted. I am taking first polynomial as it is. Try to take the folded version of second polynomial. So what is the folded version of second polynomial, sir? 1, 3, 4. It is like 4, 3, 1. Because in convolution, one signal remains same, other signal is folded and shifted. So I am taking first polynomial as it is. I folded second one. 1, 3, 4 samples. Flip it. 4, 3, 1. After folding, start shifting. If you start shifting, you got some overlap s square into s square. That is s power 4. Keep the result aside. Take one more shift, sir. Again, there is certain overlap. We take one more shift. Again, there is some overlap. What is that? 3s into s square plus 2s into s square, 5s cube. Take one more shift. 4s square plus 6s square plus s square means 11s square. Take one more shift. S square is out. 8s plus 3s means 11s. Take one more shift. That is also out. If you add all these terms, of course, that is a product of both the polynomials. But how convolution is different from ordinary multiplication means extra folding. Extra folding. Why that extra folding is needed means the reason whatever the impulse response or system we are designing, it has to detect the signal even in the noise environment. It has to detect our signal even in the noise environment. Indirectly, it must have maximum energy or power, sir. When that system can have maximum energy or power means only when first folding is done, later on shifting is done, that chance is there. Why folding is required in convolution means what is the answer, sir? Whatever the system we are designing, it has to detect the signal even in the noise environment. Indirectly, it should have maximum energy or power. Indirectly, it should have maximum energy or power. So when the system can have maximum energy or power means only when you first fold, later on shift the signal, that chance is there. So you only tell me how to give theoretical definition of convolution, sir. Sliding one polynomial over the folded and shifted version of other polynomial, we got the output. I kept one polynomial as it is, but I slided the folded and shifted version of other polynomial on existing. In that process, we got overlap or not. So sliding one signal over the folded and shifted version of other signal. Over the folded and shifted version of other signal is concept of convolution. Take one signal as it is. Try to fold and shift the other signal. In that process, wherever you will get overlap, that becomes convolution result. Everyone go through the procedure first. Please go through the procedure, everyone. Take one signal as it is. On that signal, try to fold and shift the other signal. In that process, wherever you will get overlap, that is convolution result. What, Girija? Are you sleeping? This is not overlap. S square into S square. We are placing the second folded and shifted version on the first one, ma. So in the process of sliding S square into S square is not overlap, S power 4. Next time S square into 3S plus 2S into S square. We want to fold because whatever the system we are designing, it has to detect the signal even in the noise environment. So that is possible only when you first fold and later on shift the signal. That is what matched filter. Probably some of you are aware matched filter concept. There we are studying impulse response is folded and shifted version of original signal. If you first fold later on shift, then the system has capacity of detecting the signal in easy manner. Okay. Let us solve few examples. I am going to next slide. First, I am explaining general method, graphical, mathematical tricks. Probably tomorrow's class we will see. General procedure I am explaining first. Graphical method. Suppose x of t is e power minus 2t ut and h of t is u of t minus 3. How to do convolution of them? Decaying exponential and step functions are. First you draw the signals graphically. Mathematical expression is given. Draw the signals graphically. Carry, some fellows are hiding. 4 or 5 members are coming and going continuously. Take the graphs of the functions. First one decaying, next one step function starting from 3 sap. Before following that folding and shifting, I am adding one extra step here. Try to get the limits of output. Without doing convolution, we are in a position to observe for what time resultant output is defined, sir. That is based on a thumb rule. What is that thumb rule? Is sum of lower limits less than t less than sum of upper limits. Without doing convolution, we are in a position to know for what time the resultant output graph is possible. What is sum of lower limits for both the signals? 0 plus 3 less than t. Upper limits infinity plus infinity. It is confirmed from the first step. Output is there only for which times are t greater than 3. We can clearly show that for t less than 3 output is 0. We can clearly show that for t less than 3 output is 0. It is a thumb rule. Sum of lower limits, sum of upper limits. Second step here is change of axis from T to tau. Change of axis from T to tau. There is no change in the signal shape. Only the axis changes, sir. X tau with respect to tau. H tau with respect to tau. What is the need of changing the axis, sir? If you see the definition, integration is done with respect to which variable? Tau. Integration is done with respect to tau. That is the reason change of axis from T to tau. Now let us follow folding or flipping. Folding, it is also called as flipping. Which signal is easy to fold, sir, in the problem? Which one is easy to fold? Constant signal is easy to fold. So 3 to infinity now becomes what? Minus infinity to minus 3. Constant signal is easy to fold. So I have selected it. 3 to infinity becomes minus infinity to minus 3. After folding, the next step is what? Shifting. This folded signal must be shifted. From the folded signal to get shifted signal, what we have to do is, to the existing limits, add the variable t, sir. Existing limits are minus infinity to minus 3, just add t. From the folded signal to get shifted signal. So what is the shifted form of that signal means? Existing limits are minus infinity to minus 3. For that, add t. It becomes t minus 3. See here. From the folded signal to get shifted signal, here limits are minus infinity to minus 3. For that, I added t, sir. Let me explain how we got that limit. What is mathematical expression of ht, sir, from the graph? What is the mathematical expression? 1 for t greater than 3. So what is h of t minus tau? 1 for t minus tau greater than 3. T minus 3 greater than tau. Tau less than t minus 3. We should express in terms of tau because integration is done with respect to tau. So less than t minus 3 means what is the upper limit we got, sir? T minus 3. That is what we have taken directly. All this stupid maths is not needed. From the folded signal to get shifted signal to the existing limits, add the variable t. From the folded signal to get the shifted signal to the existing limits, add the variable t. Folding is over, shifting is over. What is the next step, sir? Folding is done, shifting is done. Next step is multiplication. Which signals we want to multiply? H of t minus tau and x tau. X of tau and h of t minus tau. These two signals we have to multiply. X of tau remains in its position. On the signal x of tau, we are moving h of t minus tau. On the signal x of tau, we are moving h of t minus tau. So how to start the problem? What is the lower limit of x tau, sir? Idhar dekho. Lower limit of x tau is 0. But upper limit of shifted version is what? T minus 3. In the first case, suppose we assume T minus 3 less than 0. Assume in the first case, shifted signal has not entered the other signals. Assume in the first case, shifted signal has not entered the other signal. X tau remains same. Shifted signal covers from minus infinity to T minus 3. So T minus 3 less than 0. Do we have any overlap, sir? No. Output is 0 for T less than 3. X of tau remains same. Shifted signal covers from minus infinity to T minus 3. First case, we assume T minus 3 less than 0. For understanding purpose, other signal I am showing as dotted one, sir. Other signal I am showing as dotted one. T minus 3 less than 0, no overlap. Of course, that we know in the first step only. In the first step only, what we decide? Output is there after 3. So before 3, what will be the output, sir? 0 or not? Before 3, output is 0. Assume in the first case, shifted signal has not entered the other signal. Shifted signal has not entered the other signal. What is the second case now? T minus 3 greater than 0. Because it is other signal continuous, you can enter T minus 3 anywhere between 0 to infinity. X tau remains same. Shifted signal covers from minus infinity to T minus 3, where now T minus 3 can be positive. T minus 3 can be positive. So what is the shaded portion? Dotted signal and thick signal are combined for a certain range 0 to T minus 3. That is the range of tau for which our integrand is not equals to 0. Convolution limits are not from minus infinity to infinity, sir. According to our stupid formula, they are from minus infinity to infinity. But now, now we have valid range as what? 0 to T minus 3. X of tau, what is xt given? E power minus 2t ut means x tau is e power minus 2 tau u tau. H of t minus tau is 1. Just integrate, you will get the answer. Just integrate. So this is the answer valid for t greater than 3, sir. This is the answer valid for t greater than 3. When we assume t minus 3 greater than 0, we got overlap for the range 0 to t minus 3. So by looking at case 1, case 2, what you can say from the board? We kept x of tau in its position, but on the signal x tau, h of t minus tau, that constant signal is moved. In that process, where you got overlap? In that process, where we got overlap? T greater than 3. What ma Girija? What is that question? Huh? First case, we are assuming shifted signal has not entered the other signal. What is the upper limit of shifted signal? T minus 3. What is the lower limit of other signal? 0. I am assuming in the first case T minus 3 less than 0, no overlap. Second case, directly enter T minus 3 for the interval 0 to infinity because it is continuous. If it is discontinuous, maybe we have to split the intervals because directly decaying is continuous, T minus 3 greater than 0. That is two cases. Actually, what is the theoretical statement you have made? Everyone look here. Sliding one signal over the folded and shifted version of other signal is the concept of convolution. That is what we have done here or not, sir? We slided h of t minus 2 on x2. We have slided h of t minus 2 on x2 such that we got overlap. Actually, one point of observation is our input is causal function, system is also causal function. Resultant output is there for what time, sir? T greater than 3 means it is also causal. Input causal, system causal, output also causal. Convolution of two causal signals is causal. Convolution of two causal signals is causal. Correct or not? I will give one more model for you. Respond the answer in chat box. Take 10 minutes time. How much you have really understood, I will know. Suppose the input is given like this. Other one is given as step function, sir. Perform the convolution. First example, both signals I have chosen of infinite length. Both signals. But this problem, one signal finite length, other one infinite length, sir. Think of. Now you write mathematical expression xt is t for 0 to 1. H of t is 1 for t greater than. Blindly follow the procedure. Limits of output, all that. Make a try. According to thumb rule, what are the limits now? According to thumb rule, what are the limits, sir? 0 to infinity. Sum of lower limit 0, 0 plus 0, upper limits 1 plus infinity. 0 to infinity, sir. Carry on. Second step is change of axis from t to tau. X tau with respect to tau. H tau with respect to tau. Next is folding. Which one is easy to fold? Again, constant signal. Next, go for shifting. From the folded signal, how we got shifted signal? Last example. From the folded signal, how we got shifted signals are? Just add the variable t. Minus infinity to 0. Add t means minus infinity to t. From the folded signal to get shifted signal, to the existing limits, add the variable t. Actually, what is the significance of this t, sir? The significance of t is it will tell us what is location of h of t minus tau with respect to other signal. It will tell us what is location of h of t minus tau with respect to x of tau. Of course, not only that, t also decides our thumb rule limits 0 to infinity. T determines what is the location of one signal with respect to other signal. Gaurav Kumar, 2 answers will be there. Now our job is finding overlap of x tau and h of t minus tau. What is the first possible case, sir? Assume the shifted signal has not entered the other signal. Assume the shifted signal has not entered the other signal. That is t less than 0. When you say t less than 0, what is the product x tau into h of t minus tau? X tau remains same. Shifted signal covers from minus infinity to t. No overlap. Output is 0, sir. First case is only for fun. We already know it. Second case, because the other signal is now finite length, enter t value between 0 and 1, sir. Because the other signal is now finite length. X tau remains same. H of t minus tau like this. So yt is integral 0 to t. What is the shaded portion? This hatched area or shaded portion is only for your understanding. For what range of tau overlap is there, sir? Only for your understanding. As it is mathematical expression of the signal, we should write x tau is tau, shifted version is 1. Because already we have written xt as t. So x tau is tau, shifted version is 1. T square by 2. What is the last case, sir? T greater than 1. Again, x tau remains same. Shifted signal from minus infinity to t. As t is greater than 1. Where you got overlap, sir? 0 to 1 range, both signals are there. X tau is tau, shifted version is 1. 1 by 2. This answer only for 0 to 1. This is after 1. Here we got one more extra case. Kiran Kumar, Vignata, Gaurav Kumar, good. Blindly following that methods are graphical method. But in competitive exams, they will ask find the output at a particular instant. They will not ask directly perform convolution. That model, tomorrow's class I will explain. Today I want to end the class with a beautiful question. Let me see how many of you will give me prompt answer. Okay? Think of this. Suppose z of t is given by some integral. Try to express zt in terms of yt. Already every one of you know what is standard convolution integral, for which a small change is done, sir. Then how to write zt in terms of z of t in terms of y of t? Try to modify the given integral like convolution formula. Try to modify the given integral like convolution style. Integral x tau h of t minus tau d tau style. For that, assume any one bracket term as lambda, sir. You may get the answer. Assume any one bracket term as lambda such that it can be modified to our form. Respond. I am giving chance for you only. How to write z of t in terms of y of t? I am expecting answer from you. What Vishal Kumar? What is my question and what you are saying? Tell me what is z of t in terms of y of t. That you tell me. Assume any one bracket term as lambda. Simplify. You will retain the answer in terms of y of t, sir. Come on, come on. Suppose I have taken t plus tau as lambda, second term. Then d tau becomes d lambda. Then d tau becomes d lambda. Venkat Ramana correct. Kiran Kumar correct. Nitish also correct. As tau and lambda are having same sign, limits of integration are same again. So x of, instead of minus tau, what I have to write, sir? If I take tau this side, instead of minus tau, I should write t minus lambda plus a h lambda d lambda. So that becomes integral of x of t plus a minus lambda h lambda. In the place of t, what you got? T plus a. So answer is y of t plus a by definition. The fellows who are assuming the first term as lambda, be careful. You have to change the limits also. Minus d tau is d lambda. As tau and lambda are having opposite sign. In this case, plus infinity to minus infinity. But still, final answer is same. It will not affect the final answer. The fellows who have assumed first term as lambda, be careful, sir. You have to change the limits. Finally, same answer, y of t plus a only. Okay, just I have given a basic idea of convolution. Another 2.5 hours, we are going to discuss so many models related to continuous. Evening sessions, generally I will take till 8:45. After that, I cannot continue. So maybe the session is for 9 o'clock. Don't be that much emotional towards it. Till 8:45, generally I may take the sessions. Okay. That's all for today. Good night. Nitish, I have given the answers now. Acha, rectangle, that question. A square plus B square plus AB. I think the other one 224 by 3. A square plus B square plus AB. For that rectangle, probably. The other one 224 by 3. Jyotisha, for you, I can't change ma. Go on saying the same statement. Over the years, I'm using whiteboard. Suddenly, if you ask me blackboard, you do one thing. Better you attend offline session. What best is possible with me, I will do.
Good evening, sir.
Yes, ma, tell me.
Sir, before this problem, sir, how you take the limit from 0 to t, sir?
The other signal x of tau is covering what length, ma? 0 to 1, na? It is a finite length signal or not? Are you there? Ghana. Hello? Okay, just listen. Other signal 0 to 1, it covers. Our target is sliding this constant signal on this. So first I entered the t limit for 0 to 1 range.
Hello?
Arey, what happened, ma? Are you there? I am shouting like anything. Are you there? Hello? Hello? First I entered between 0 to 1. We solved, we got something. After that, I assume t greater than 1. Then you got overlap of both signals for 0 to 1 range only. Okay, that's all.